In this video, we will discuss reducing character of oxides of group 16 elements. So, in group 16 elements, sulfur dioxide, selenium dioxide, and tellurium dioxide. These are there. As we move down the group, the reducing character of these dioxide decreases. So, reducing properties or reducing character decreases down the group. This means that this will be a better reducing agent and this will be a better oxidizing agent. In other words, we can say like reducing character is decreasing, but oxidizing power increases as we move down the group. For this, you need to understand what is oxidation and what is an oxidizing agent. So let's have a recap of this. Oxidation is the process in which addition of oxygen takes place or removal of hydrogen takes place. In terms of oxidation number, there is increase in positive oxidation state, so increase in oxidation number, or we can say loss of electron take place whenever oxidation is taking place. So at that time loss of electron take place. Now how do we define oxidizing agent? So oxidizing agent is any species which can easily give oxygen to other species, so that is an oxidizing agent. In terms of electrons, if we are defining oxidizing agent in terms of electron, so the one which accept electrons, so the species which accepts electrons is known as oxidizing agent. Okay, so now just look here as we move down the group. So for the here, as we move down the group, what will happen here? Size increases. That means TEO, the bond length, this bond length. So this bond length increases, and because this bond length increases, that means we need less energy to break this bond. We can easily break this bond. So bond dissociation enthalpy is less here, and we can easily remove oxygen from this bond. So because this can easily release oxygen, so it oxidizes the other species, and therefore it behaves as an oxidizing agent. So therefore it behaves as an oxidizing agent. So again I am repeating, as we move down, what happens? The size increases. So in this case, what will be there? The bond length will increase, and as a result the bond dissociation enthalpy for this will be less, and we can easily break this. So when we can easily break this bond, that means the removal of oxygen from this bond is very easy, and therefore this is behave as an oxidizing agent, because the one which can easily give oxygen, that is the oxidizing agent. So this will behave as an oxidizing agent. Let us try to understand this thing in terms of electrons. So let me take example of sulfur dioxide. So in case of sulfur dioxide, the sulfur is having +4 oxidation state. Okay, so if it forms, it goes to +6 oxidation state, as in case of sulfur trioxide. So what will happen, that means this one is the lower oxidation state and it is moving on to higher oxidation state, and +4 to +6, that means it is losing 2 electrons. So 2 loss of electron is taking place. So that means here oxidation is taking place and this is behaving as a reducing agent here. Okay, and what will happen, like if it goes to from +4 to -2 oxidation state, that means like it gains electron at that time. So gaining of electron happens, so at that time it will behave as an oxidizing agent. Now sulfur dioxide, it is a good reducing agent, and it easily prefer to go to +6 oxidation state. So the reason is because it is having, sulfur is having empty d orbitals. So empty d orbitals is there, and therefore it can expand its oxidation state from +4 to +6. So it oxidizes itself and reduces other. So sulfur oxidizes itself and reduces others, and hence it behave as a reducing agent. In case of TeO2, again here the oxidation state is +4. Okay, so this can't go from +4 oxidation state to +6 oxidation state, and the reason is because as we move down the group, so down the group what happened, that the +6 oxidation state is less stable, and the reason is because of the inert pair effect. So it can't go from +4 to +6, but it will prefer to go to lower oxidation state, and if it goes to lower oxidation state, so at that time it will behave like, if sulfur goes to -2, so at that time it will behave as an oxidizing agent. So if this goes to lower oxidation state, so it will be behaving as oxidizing agent.